This video is part of CAE Associates ANSYS e-learning series. CAE Associates is an engineering consulting firm in Middlebury, Connecticut, specializing in finite element analysis and computational fluid dynamics. We have been an ANSYS channel partner since 1985 and have developed our ANSYS e-learning series to help you maximize your software investment. Please visit our website, which includes an extensive resource library with over 250 items and counting in an easily searchable area. We also invite you to visit our Engineering Advantage blog, where we share insights from our many years of performing engineering analysis. CAE Associates also offers an extensive schedule of ANSYS courses taught at our Middlebury office. If you need help deciding on the best courses to take for your application, visit our CAE University page. The complete library of e-learning recordings is available for viewing in our resource library and also on our YouTube channel at youtube.com/CAEAI.
I open up Workbench and show you how to put in command blocks and how to use them. I just want to preface this by explaining to those that maybe aren't familiar with command blocks what they are and kind of what we're doing when we're using command blocks. So to start off, you're probably familiar with Workbench, at least Workbench environment. This is, you can set up your model and solve and everything in this interface. However, when you hit the Solve button in Mechanical, you're actually writing out an input file. You're opening up ANSYS Classic in the background in batch, and that input file gets submitted to ANSYS Classic. And then ANSYS Classic runs the analysis, and then when it's finished, the results come back into Workbench. So, this is a seamless process where when you're in the Workbench environment, you might not even know that this was happening, but this is understanding this is really what we're going to be talking about today, and that we're dealing with this input file that gets created from Mechanical. So everything that's in Mechanical environment that you see has to get written out to a corresponding ANSYS Classic command, which is your full model that shows up in Classic where it's solved. So this is really what we're going to be talking about today. How do we interact with this input file? How do we stuff our own commands into this to control different things? So if you wanted to see that input file, it's very easy. You can just go into Mechanical, highlight Solution, and Tools, Write Input File, and that will write out that text file. It's just an ASCII file. You can open it up, and you'll see that everything in there is everything that was in your Mechanical session. In terms of the finite element information, though, loads, boundary conditions, mesh, the geometry will not be in there, though. So just keep that in mind. But that is the entire input file for your model. And you could just as easily open up Classic ANSYS, choose File, Read Input From, and read that input file in, and then you'll have your entire model that was in Workbench in Classic ANSYS and see everything that's in there. So, you might ask, since we're going to be, doing some things in Classic ANSYS with command blocks, why don't we just build a model in Classic ANSYS from the start and then stay in here and not have to worry about Workbench? That's certainly an option to you, but if you start off with Workbench, there's a lot of nice features that help speed up things, and things are automated for you, and that it links very nicely with your CAD systems. You get parameters, you get bidirectional associativity between that, so any changes you make in your CAD end, those can flow through all the way down. A lot of times you just have to hit refresh, and the whole analysis reruns, your boundary conditions, loads, and everything stay on the model. So that's something that's very nice and easy to have. There's better or nicer, more robust meshing methods, and then some automatic contact detection between the bodies. A lot of these things really speed up the analysis time that aren't, say, as available in Classic ANSYS. So that would be the reason to use Workbench, but there might be just something specific that you want to tweak with a command block, like maybe different element types, put in some material properties, change some settings here and there in the analysis that might not be available in the Workbench GUI. So that's where command blocks come in. You just make those changes that you would like. And you might also have some scripts that you're used to using all the time, doing some post-processing, setting up different things. You can still use those scripts. You just need to stuff them into a command block. So that's kind of high level what we're talking about here. And the last slide I have before I go into Workbench is the outline tree is structured basically from model to the analysis environment is everything in pre-processing in classic ANSYS. Under the analysis environment is everything in solution, and then solution here is everything in post-processing. So the input file is essentially structured this way. So we can set up different command blocks in these different locations to access different information. So that's just a quick introduction. So I will go over here. I have a model already set up in Workbench that's already solved. It's a half symmetry model of a pillow block, just a bearing load on one, and then I just fixed the bottom down here on the other side, and I have some deflections and stress. I'll just use this as a simple model to demonstrate some command blocks. So what if we wanted to do another analysis on this? So I can go into the project page and then just drop another static structural in here, and then we can just put in the same loads and same results in here. So I could go set up, and then maybe in this case I put on some different boundary conditions and loads and solve this other analysis. Sometimes it's nice to set it up this way because then you can maybe use a chart or compare the different results between these two analysis blocks. But one thing that we're not able to do with this type of setup is if we change any connections or maybe want to change the material properties on a body, everything that is in this tree above this first environment gets shared between these two. So with this type of setup, there's no way to change the material properties for this one analysis block and not affect this one. But that's very easy to do with a command block. We can do something like that. We could set this up differently in Workbench and be able to run this, but just to illustrate this, so on the body, if I insert a command block, then you'll see there's some text that shows up in here that commands inserted in this file will be executed just after material definition in Prep 7, that's preprocessor, and then the material number for this body is equal to parameter mat ID. So on this body, this is going to go into classic ANSYS. It's going to get a material assigned to it, and the material number is going to equal mat ID as the parameter there. So I'm just going to save that number, whatever it is, maybe it's 1 or 4, as my own parameter. Just store that. And then I will go down into the next analysis branch down here and insert a command block in this location. And notice that commands inserted into this file will be executed just prior to the solve command. So we're in solution, and I'll insert a solution command, which this works. I'm going to change the material properties. So this defines a material property modulus of 10 to the 6. And I'm using that parameter again. This is a number that is equal to the material that's assigned to this body right here. So what I'm actually doing in this case is I'm overwriting the existing material that's already on the body. So we can go and solve both of these, and we'll just take a quick look at what's happening here. Let me solve that, and then we'll also, while this is running, we'll take a quick poll. So there should be a poll window that will pop up on your screen in a second. So if you go ahead and answer this question, are you currently able to add command blocks on your own? I just want to get a feel for who might be using it, or if you're familiar at all with them. So please go ahead and submit your answer. Looks like most everyone has submitted, but some are still working, so let's give you a little bit more time here. All right, looks like that's probably going to be about it for those that are going to respond. So I will close the poll, and I'll share the results with you. So it looks like 40% have, so that's great, and then I think it's another roughly 40% haven't or could with some help. So that could be either from difficulties not knowing classic ANSYS or just didn't know the feature was there. But if either of those are the case, you can certainly give us a call, and we'll help you get going if there's something that you want to do and maybe just need a little help to get going there. So this model's finished. So if I go back and look at what happened here, So this was the original analysis. There's a stress on this pillow block portion, like 1350 psi, and then look at the stress on this next part, and it's about 1,000. So we can see that that did change the material, change the stress in that body. So that command block did work. But one thing that I want to bring up with that command block that I inserted is that I hard-coded in a number. 10e to the 6 was assuming English units. When I inserted the command block, those were the units that spit out right here, that the unit system was, inch pounds. So if I went in at this point and used units, changed it to metric, then this command block is going to be no longer going to be valid. So you have to be careful of that. And another example of that, too, is also in post-processing. If I insert, say, grab the strain energy for the body, or for everything in the model, this shows up as 1 to the minus 6 BTUs. So I could get this same information through a command block, and this is the first post-processing command block we've seen, where file commands in here are executed just after post 1. So we're in the general post-processor classic ANSYS. So the first thing that we need to do when we're in there is read in a set of results that we're interested in. So we do that. I just element table all the elements for strain energy. I sum up that element table, and then I get the summation from that, and I store that as a parameter here. I'm just going to evaluate this while I talk. So I set up this parameter name specifically with my underscore as the prefix, because if you notice in the details of this command block, there's a search output, my underscore. So as long as we set up whatever the prefix is in here and make our parameters match, then those will show up in the results down here. So you can see them, the values of those show up in here. And you could check this box and make a parameter out of that. I'll come back to that at the end of the webinar. So one thing we'll notice here is that if we just element table the results and then spit that number back in here, this is 1 to the minus 2 as opposed to 1 to the minus 6 type order of magnitude. So you might say that what's going on here, and it's just that these are the GUI shows up as BTU units, and then the units here are the consistent English inch pound units. So we just need one more parameter here. I just divide that value I got by 933.8, and then you can see that value matches up down there. So you just have to be aware of the units. So this has always been one of the concerns with Workbench, has been the lack of consistent units in classic ANSYS. So Workbench converts all the bin thermal units, or basically the BTU quantity, into equivalent pound units when it goes into classic ANSYS. So when you have the mechanical database and you export or run it, it's going into classic ANSYS. All material properties, loads, anything that needs to get converted to consistent units does. That also means that in post-processing, classic ANSYS, those are still in those consistent units, but Workbench converts them back. So that's really the key here, is just remember that that's the case. So it's easy enough to convert it, just as long as you're aware of that. So that's one example. Let's maybe get a little more sophisticated with this problem now. So what if we wanted to take this body right down here that is a structural steel and convert that into a composite, essentially, with a layered shell definition in those. Since this is a solid body, that's something that's not available currently in the GUI. You do see this button right here is layered section is grayed out. If I did have a surface body in here, that is a feature that's available in this GUI. But layered sections on solid bodies is something that's available in classic ANSYS, so we can access that functionality in Workbench through the command blocks. So the way to set that up in here, if we just take a look at the mesh that we have on this body. Those are just some solid elements, and I use the thin sweep method where I drop the mid-side nodes and use the solid option. So these elements that are in this body are going to be the solid 185 elements, and that thin option, automatic thin, just orients the elements such that the through thickness direction on this plate is aligned with the thickness of the elements. They're just all oriented the same way. for this to work. So on this solid body, I'll insert a command block, and then it says here that parameter mat ID is equal to the material number. That's true. What's also true is that on this body, the element type, real constant section number can also be the same. So what we can do is we can access the element type for that body through mat ID as well. And I'm going to change the key options for those solid 185s. I'm just going to make it a layered solid, and then I'm going to store all the information for all the layers with these two changes. So that's easy enough to change some of the options on the element type, but I haven't done anything in terms of assigning the sections to those elements. So we can do that by inserting another command block. Do this in the analysis environment. Put in a command. And then in this command block, again, it's right before the solve, so we're in solution, but this is one big long input file that gets created and then submitted to ANSYS Classic. So as long as you know you're just writing out an input file at the end of the day and stuffing in your own commands where you want, you can really do whatever you'd like. So there's no reason I can't go back into the preprocessor, do a bunch of stuff in here, and then go back into solution afterwards. That's perfectly fine. So that's what we're doing here. So the first thing that I'm doing is I'm selecting some elements. Now, this is really the key of how I'm tying this command block into the geometry that I'm working with, or really the elements I'm working with. So I created a name selection on the body right here called sandwich for that little sandwich piece on the body. So if I do that, then this is an element component that gets created and sent over to Classic ANSYS. So I can use these name selections as components and select them. If it was a surface edge or point, then it would be a name. That name selection will go over as a nodal component in Classic ANSYS. So on this command block, I am selecting those elements based on that name right there. So I select those elements, and then I get the material section and type numbers in here. Pretty much, it does the same thing, a little bit different than that first example of using that parameter, but this does the same thing. So I get that information, and then I overwrite the existing material properties that are in there and put in some composite properties, and then also the section properties for the layup in there. So those are the commands for doing that, and then go back into solution. And then this outres command is something I generally put in if I'm doing something specific with command blocks. The reason for this is that this will write out all the results possible to the results file. In Workbench, if I go down to analysis settings, output controls, you'll see that these outputs for nodal forces, contact things, Workbench turns off a lot of the output to help reduce the file size. But I want to make sure that since I'm putting in other elements, these are going to have their own unique results. I want to make sure that those results are written to the results file. So generally, I'll always put that in just to make sure that I have the results in there. Okay, so I can solve this model now, and then we can see the effect of putting in that command block on the stress. So the stress used to be 1350, now it's 1400. So we see a difference in the results. We can also see the deflections and everything, but this is kind of the thing to keep in mind is that Workbench only knows what it creates, right? So I created some layered elements down here, but they don't show up that way. It doesn't know that they exist. The results are due to those being in there because they went into Classic ANSYS. Classic ANSYS knows that those are layered elements, but we really don't know that in this GUI. So let me insert a command block in here, and then we can do something with post-processing to see those. So this command block, it starts off by resuming the database. Under the analysis settings, I set to save the ANSYS Classic database. I only did that so then I could read in the components that get defined, which is that name selection. Those don't get stored on the results file. Otherwise, we just read in the set of results. So that's why it's in there. So I select just this body down here, and then I'm going to create a plot of that. So let me evaluate this. So this command, these are just some view settings, and then this is /show PNG. We'll take a picture, and it's going to take a picture of the stress in the X direction for just those elements that I selected. And you'll notice if you put in /show PNG, it'll put in a picture below the command block. And this is the picture that we see in classic ANSYS if you were to write out the input file, read the results in, and look at it in that GUI. So that picture shows up in here. And we can see that those are those elements do have 10 layers through them. I turned on the edges so that we could see that. And then you see the stress distribution in those elements. So, it did make that change. We can see those results in there that way. So, that's one example. There's some more things that we can do with this. But let me just take another quick poll. Let me just give me a second to open it up here. Okay, so the next poll that we can take, so have you had a situation where a command block could have helped? So now that you know a little bit about them, do you think that there's a case where maybe something was in the GUI that you feel that you could have got around it with a command block? And if you have created a command block, there's not a way to, through the poll, to submit your answer to that. But if you have created one, and you wouldn't mind submitting through the chat window what the instance was where you needed a command block, certainly wouldn't mind sharing some if anyone wants to submit that. So I'll just give you some more time here to finish with the poll. And looks like that's going to be about it. So I'll close the poll here in a few seconds. And someone said they've used a command block to tie some coincident nodes together. There's certainly going to be many uses for command blocks. That would be one of them, to merge them nodes together. All right, I'm going to share the results with you. Anyone else want to submit their uses for their command blocks that you've created, please go ahead. So it looks like, majority did know that command blocks exist, but maybe just didn't know how to use them. And again, if that's because you just maybe don't know the commands or how to get those commands from classic ANSYS, like I said, we can always help you out a little bit if you need to kind of get going on that. So we could always point you in the right direction if you give us a call. All right. So then let me go back and show you a couple more things with the command blocks that we can do. The next thing I want to do is go into this command block here where I define the section properties. Right. So in here, these are the ANSYS commands for putting in a bunch of different layers, and they're that amount thick, and then there's a whole bunch of layers. So what if we change the geometry, right? And we wanted these thickness values to update when we did that. So if I go into Design Model here and just look at how this part was created, I just sliced this pillow block by offsetting this plane 0.2, and I made a parameter out of that, and then I sliced it. So that 0.2 parameter corresponds to the thickness of that body right there. So that's a geometric parameter I already have set up. I want to tie that into this command block that I have here. So the way that I can do that is just select arg1. That's going to turn this into an input parameter, into this command block. So what I'm going to do here is arg1 is going to get assigned a value from Workbench. And then I'm going to store that as the total thickness, and then a total thickness divided by 4 to give me the layers, because I have 4 layers in here. So you could certainly do this many other ways, or maybe you want to change the logic, but this will just show you that 4 layers get created based on the thickness of the geometry parameter. Now, I've set this, but I need to link those two together. The way that I do that is go to the project page, highlight the parameter set to go in here, and we see we have that geometry parameter of 0.2, and then I have this parameter from that command block that shows up as arg1. So if I highlight this parameter and go into the properties of that, I can set an expression where I put in P4, which is the value of that geometry parameter, and now this is a derived expression where those two are now linked up in here. So I'll refresh to send that parameter back into mechanical. And now I have that command block, and I see that we have a value associated with this parameter ARG1. So now this is going to be 0.2, which gets put in here, and so on. So if I resolve this model, then it should take on that value. And then we can look at the picture and then see that it did update everything. So just about done. There we go. So now we can see that picture. There are now 4 layers through those elements, and looking at the stress because of that. So now those are parametrically tied together, and then, like I said, in the output parameters I had here, and those could also be parameters as well if you wanted to do something with those. So that's using some parameters that can be useful. There's one more thing that I want to show you, I think, that we can fit in the time, is that if I made this a multi-load step analysis, right, so I set this to 2 load steps. Now when I highlight on this command block, this shows up where you can set the step in which you want that command block to be applied. And now this is the first step. So if I insert a second command block in here, maybe I want all the commands that are inserted in this command block to be executed on a certain load step. Maybe I'll say load step 2 in this case. So load step 2, what I'm going to do is maybe I just grab those composite elements and kill them, or remove the stiffness from the simulation and the second step. So this would do that. So we run the first analysis with this command block, get the results, and then the second step, maybe the properties have degraded, or whatever you're doing, you want to get rid of that for some reason. We do that on the second step. I will mention, though, that since this command block gets executed as the second solve in a multi-load step analysis, you want to be careful what you put in here. You wouldn't want to put in, go back into the preprocessor and then go back into solution, because then that's going to, basically start the analysis over where you overwrite the results that used to be there previously. You need to stay in the solution processor if you're going to put in commands on a certain step to keep everything, just the way it needs to be. So that's it for the time that I have. So I'm going to switch back here. If you're interested in any other e-learning webinars, please check us out online, and you can see the ones that we have coming up. Let me just see if we have any questions here. Okay, I just talked about parametric variables. We went through, can you make surface effect 154 elements to add a pressure? You certainly can. You can create a name selection on a surface, something like that. That'll go over as a nodal component. And then your command block, you'd want to grab those nodes, and then you could, depending on how you do it, you could set up element type with surface 154, and then you got those nodes, and then do an eSurf on that. That's something that you can also do for 2D analysis if you wanted to put convection in the out-of-plane direction, which isn't something available in the GUI. So you can certainly do things like that too. Any other questions? Okay, one related to the APDL language. If you want to figure out how to use these different commands and what's really needed, I'll go to the presentation here quickly. I'll say that the best way is to just do what we have here, where you write out that input file and then open up classic ANSYS, and then work your way through the GUI by clicking on and manually doing what you would like in here. And then if you choose, there's under this list menu, list files, log file, you can see the exact commands for what you did in the GUI. And also all the commands are available in the help too. So that's, I'll just say really quickly, probably the easiest way to get started. But if you really have a question, want to get going, just give us a call. All right, so I think that's it. Anyone else that submits a question, I'll just reply to you by email. And thank you for attending. and please join us in any of our other upcoming webinars.